So for part 3 of your procedure, you're going to be using unknown number 2. Now remember, this is the unknown that has calcium carbonate and sand. Now, if you look at this material, or if you look at this mixture, you might be able to see that, oh, it doesn't look exactly like sand because it's kind of white, but if you were to try to separate these components, that'd be a bit of a challenging task. You'd have to have tweezers that are extremely small. That's not something we're going to do. Instead, the way that we're going to approach this is we're going to get approximately 10 milliliters of HCl. So you're going to use your graduated cylinder to transfer that HCl into your small beaker. Then what you're going to do is you're going to determine the mass of your evaporating dish. Now this evaporating dish, it's ceramic. It's fairly strong, but you definitely want to be careful with it. What I'm going to do is determine the mass of this, and I'm going to transfer approximately 2 grams of my mixture into this evaporating dish. So 2 grams of this unknown number 2 into my evaporating dish. So I've got my evaporating dish there. Now, what I'm going to do after this is I'm going to transfer using what's known as a transfer pipette, which if you look at the side of this, you've got these graduations or little markings for 0.5, 1, 1.5, or wait, no, 0.5, 1, 1.5, 2, 2.5, and 3 milliliters. So this has a way that you can measure approximately 1 milliliter, approximately 2, and so on. What I'm going to do is I'm going to very carefully transfer in a dropwise fashion some HCl into my mixture. The reason that I'm going to use HCl is because here what we're illustrating is a chemical separation. Because one of these 2 substances, spoiler alert, it's the calcium carbonate, is going to react with my HCl. So if you look, look at that. What you definitely want to do is swirl your solution so that we get a complete reaction. Now there is some gas that's forming, but don't worry, that's carbon dioxide. And look, there's some more carbon dioxide. So I'm going to continue adding HCl until the reaction no longer takes place. And you can kind of see a little bit of white powder, some of that calcium carbonate that's still there. So I'll do this a couple more times, make sure that I get all of it. Make sure that I add an excess, but maybe not too much of an excess of my HCl solution. It might take a little bit more than your 10 milliliters, hopefully not. Still going, still going. Okay. So now what I'm going to do is I have this solution, which I'm going to try to tilt my camera, this solution right there. And now I'm going to do a separation technique, or a way of separating substances, separating a liquid from a solid. And this is something that you've probably actually done whenever you've, let's see, what's an example? If you boiled vegetables or something like that, if you made broccoli, one thing that you can do is either strain it, or you can do what's known as decanting. So what I'm doing is I'm trying to pour off all of my liquid, but keep my solid in this evaporating dish. So if you look here, there's my sand still in there. Now the next thing that you're going to do is you're going to wash that sand a total of 2 times with deionized water because you want to dilute out as much of that HCl as possible. But what I've done is I've separated. That's a physical separation that follows a chemical reaction. So it's a chemical reaction that my calcium carbonate goes into solution and then breaks down into a carbonate ion and calcium ions. And that carbonate ion subsequently converts into carbon dioxide, in which case that's broken down and released. So that in a nutshell is what this lab consists of, where you separate these components, and we're learning how to separate them and evaluate basically what's the composition of this. Now, for that chemical separation, you're going to get data from two of your peers for trials number 2 and 3, because that takes a little bit longer. You've got to be careful with the amount of HCl that you add. All right, well, I hope this is helpful, and have a good one.